Most people think of pregnant women when they hear the word ultrasound, but these machines are used for much more than checking on growing babies. Doctors use ultrasound imaging for everything from diagnosing a torn tendon in a knee to finding blocked arteries near the heart.
The technology of traditional ultrasound is quite old. It's over 100 years.
Now researchers are working to come up with newer and cheaper ways to use ultrasound.
Inside Science.
Traditional ultrasound is basically they use tiny ceramic bricks that expands and contracts if you apply voltage. That expansion and contraction generates ultrasound waves that are used to look on the interior of your body using ultrasound waves.
Gerardo says that there's nothing wrong with the current system, but there are limitations to the technology.
So for instance, it is hard to get miniature sensors with these tiny ceramic crystals. They have a lower sensitivity than alternative technologies. In our case, we developed something called polysymats, which are basically tiny vibrating drums made out of polymer or plastics. They are very small, about the size of a human hair, 100 micrometers, and they vibrate up and down to produce ultrasound. You get a higher sensitivity, which means you can get clear and a high resolution images out of them. It is easier to fabricate and integrate with existing electronics.
Researchers are also looking at a flexible ultrasound patch made of plastic, which means it can form itself into any shape on the body for a better reading. It could be cheaper too.
The average cost of an ultrasound system is close to $150,000, which is very often prohibitive in developing countries or struggling economies. So one of the main impacts will also be to access and to give the opportunity of to these economies to acquire high quality ultrasound systems for a very reasonable price. Our deal will be something that costs $100 or less. That's our dream. But obviously there are many different factors that can affect the final price. We are trying to bring this technology closer to the reality. So for instance, we have had talks with very important ultrasound manufacturers and companies trying to integrate this technology either into their own products or develop a completely new product with this technology. So that will allow us to bring this into a more tangible way in the shorter term.
This is Inside Science.
Inside Science. If you enjoyed this edition, follow us on the web and social media. Powered by the American Institute of Physics and a coalition of underwriters.